so we're going to go ahead and get going on our 9-1 and 9-2. 9-1 is going to be a review of reflections, and 9-2 is going to be a review of translations, and we're going to just take it a little bit further than we took it before. All right, so the first thing we'll do is go through some vocab. A transformation of a geometric figure is a function that results in a change in the position, shape, or size of the figure. There's 4 that we talked about, okay? So reflection we'll start with. This is what we're going to start with today in 9-1. And a reflection, it flips. So your reflection in your mirror is going to flip your image, okay? A translation is the second thing we're going to talk about today. And a translation is the slide. And I told you guys to remember it like SL for slide. We'll talk about a rotation in the next lesson. And we'll talk about a dilation in the next lesson. Okay, so of course your rotation is going to be a turn, and your dilation, we talked about our scale factors with our dilation, so this is going to be pretty repetitive from what you've seen before, and it shrinks or expands a figure. So your original figure is called your preimage, we'll use that terminology, and then your resulting figure is going to be called your image. Okay, so your preimage is what you do the translation, reflection, rotation, or dilation to, the image is what results. A transformation that preserves distance and angle measure is called an isometry. So when you guys hear isometry, I want you to think congruence, all right? Reflections, translations, and rotations are all isometries, all right, because of the fact that they preserve the shape and the size of the figure. A dilation is not, because of the fact that it's going to shrink or expand it. Those shapes are going to be similar, but they're not congruent. Okay, so all these guys right here are isometries. Another name for them is a rigid motion. You can think rigid as in firm. And they're all congruence transformations. So this is the terminology that we used before, congruence, because they stay congruent. When you slide something, it stays congruent. It just changes the position. Okay, so your reflection is the type of transformation that we're going to talk about today, and it of course flips an image to form another figure, or another image, I'm sorry. And it does not change the shape or size. So a couple properties, a reflection across line M, this is going to be called your line of reflection, all right? And so if I reflect B onto the other side, then the segment that connects these two guys is going to be perpendicular to your line of reflection. If I have an imaginary segment that connects C to C prime, that segment is going to be perpendicular to the line of reflection. The other thing is the distance between the image and the pre-image to the line of reflection is going to be equidistant. All right, so these guys are going to be congruent here. So that's what it says here. It's a perpendicular bisector. It basically is going to be perpendicular, and it's a bisector because it's going to be equidistant. All right. If A is reflected and it's on the line of reflection, it is the same point as A prime. So the image and the pre-image are the same thing. All right. And then this is a little bit of notation. You guys don't have to use this, but I just want you to see it. Reflection across line M of point P gives me P prime. Reflection across line M of point P results in P prime. All right, guys, so we'll just do some quick problems here. Just for some terminology, you guys have seen this before. All right, so looking at these two guys, of course, the orientation of the figure is going to be reversed. The orientation of the figure reverses. So because of the fact that these aren't reversed, they're not flipped, this is more of a translation. This is not going to be a reflection. This, of course, is flipped. It's reversed. This is a mirror image, so this is going to be a reflection. And again, the size and the shape is preserved. So it's a congruence transformation. Okay, when you guys get this is the one that you really need to focus on. These are going to make sense to y'all. So if I have point P and I reflect it over the x-axis, remember these are equidistant. So if this is 4, 2, then this of course is going to be 4, negative 2. Okay, you just go into the 4th quadrant. That's what this is telling me right here. Same, negated. If I'm reflecting 4, 2 over the y-axis, well, what happens? This is going to be So negated, the same. Again, this is not something that I would spend my brain thinking about. I would just think about this rationally. This is something that might help you guys though. If it's reflected across the y equals x line, that's this line right here, then what happens is that if this is 4, 2, and it's reflected across this line, these guys are going to swap. And it's going to become 2, 4. Okay? That might be something. Maybe you can remember it. Y equals x, yx, they swap. And likewise, if I go from here and reflect it over, they're just going to switch places. Okay? And then the last one that I do want to put in here for y'all is if you have it reflected across the y equals x line, which is going to be this guy right here, then your xy coordinates are swapped and negated. Okay, so for example, 4, 2, if it was reflected across this line, would come over here, and it would become -2, -4. Well, that makes sense, all right? If he's coming over here, it'd be -2, -4, and he'd be down here. All right. So we'll just go through this really quickly, guys. Again, this notation is not going to be used in your book, but I just want you to see it. So if I have the point 3, 4, 1, 2, 3, 1, 2, 3, 4, and it's reflected across the y equals 1 line, well, 1, 2, 3, 1, 2, 3. This is going to become, let's see, 3, 4. Let me go up 1, and that'll get me where I need to be. 1, 2, 3, 1, 2, 3, 4. There we go. Okay, so 1, 2, 3, 1, 2, 3. So this is going to become 3, -2, guys. And again, the whole point is just that it's equidistant. You can eyeball it and count. It's just fine instead of memorizing all the different formulas. Okay, so this is the last one we'll do, y'all, when we're dealing with reflections. And so this one, I'm going to go ahead and get these vertices down. And what it wants me to do is it wants me to reflect it over this point of reflection here, or this line of reflection. So A is -3, 5. B is -2, 1. -2, -1. And then C is going to be 0, 3. So I'm basically reflecting it over this line right here. So those are a little bit harder to eyeball. And in this case, we're going to use our pattern that we have. All right, so A prime, we're going to switch it and negate it, is going to be -5, 3. B prime is going to be 1, 2. And C prime is going to become -3, 0. Again, I switched it and negated it. So let's see here what we got. 1, 2, 3, 4, 5. 1, 2, 3. All right, there's your A prime right there. And then your B prime is going to be, let's see, 1, 2. Over 1 up 2. And then your C prime is going to be -3, 0. Okay, so this guy came down here. This guy came over here. Oh, -3, 0, guys. Where are we? There we go. That didn't look right. All right, -1, 2, 3, 0. Okay, that looks better. There we go. I was looking at the wrong drawing that I had. All right, y'all. So the last thing of this section that we want to talk about is a vector. And the two things that you guys need to know about a vector, it's an object that has both magnitude and direction. Okay, so think about it as an arrow shooting through space. Magnitude is going to be your length, and your direction is going to be the direction that it's going in. Okay, it's a directed line segment. The arrow is going to indicate the direction it's going in. All right, so this guy basically here is going in this direction. For a vector, you guys, you're gonna go from the start to the end point, and that's gonna give you what the coordinates of the vector are. All right, so you would write the notation, the vector in this direction, the horizontal change is gonna be the x value basically, your vertical change is gonna be your y value. The horizontal change is x, the vertical change is y. Let me give you guys another example just to kind of wrap our mind around it. If I gave you this vector here, the horizontal change is 4, the vertical change is going to be negative 3. All right, so it really is similar to just doing your x and y coordinates. If I had something going in this direction, it would be negative, negative. And that's going to matter here because it's going to help us with some of this notation. So we're going to talk about our translations, guys, and we're going to include these vectors in it. So this is how we're going to expand on this. Your translation is a type of transformation in which a figure, your pre-image, is going to slide, and we talked about that before. It's going to form another figure, all right? It does not change the shape or size either, so of course these guys are going to be congruent. It's a congruence transformation. So the diagram at the right shows a translation in the coordinate plane. All right, so each point of A, B, C, D is translated 4 units to the right and 2 units down. Okay, so this guy, for example, look at 1 point, 4 right, 2 down. So one way that you guys have seen it before is written like this. This is how you're going to see it now. T for translation, 4 to the right, 2 down. This is the only thing that's really new is getting used to this vector notation, you guys. It's telling you the direction that it's going in. All right? So same thing here, translation. This is what I want you to focus on. All we're going to do is we're just going to translate this guy. So I'm going to take each point here and I'm going to move it to the left 2, and I'm going to move it down 5. Left because it's negative. Before, you would have it -2, -5. So, to the left 2, 1, 2, 1, 2, 3, 4, 5. To the left 2, 1, 2, 3, 4, 5. And to the left 2, 1, 2, 3, 4, 5. And that's going to be your translation. There's your R prime, there's your Q prime, and there's your P prime. All right, take a second and double check and make sure that you didn't make a careless mistake. And then what we want to do is we want to go backwards. Okay, so we want to write a rule of how much I moved. So I'm going from my pre-image to my image, so I am going 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8 is going to be my horizontal movement. And then I went down 2. -2 is going to be my vertical movement. And that's all you guys have to do. Here, you guys, this is just another way of looking at the problem. L prime becomes 1, -2. All right, M prime becomes 1, 2, 3, 1, 2, 3, 4. N prime becomes 2, 4, 6, 1, 2. I'll squeeze him in right here. So let's just pick 1 point. We'll do L. 1, 2, 3, 4, 5, 6, 7. All right, so we move to the right 7, and then we move down 1. So this is our translation. Go ahead and label these L prime, N prime, this is what you guys will work on in class. No, actually, you guys are going to do this for your homework. All right, so this is going to be due on Tuesday. These are super quick, you guys. You do not have to graph. You guys can just go ahead and give me the coordinates. And I believe that might be for this section right here as well. So don't worry about graphing, guys, just give me the coordinates.